I haven't done one yet. I was about to make a problem. Okay. Well, let's do yours first. What's yours? Okay, let me pull that up. Number 12. Let's see, how do I see that? That's going to be one sec. Schoology. School. Okay. Okay, ready. Hang on. Well, actually, can you just read it to me? What does number 12 say? Okay. So that's 0.15. It starts from rest. And what speed does it want? And it's asking for the time. Oh, the distance. Okay, so I want to know this area. True? So it looks like a triangle to me. So I don't know this time, but the displacement, delta x, should be 1/2 the base times the height. But I don't know the time. Does that make sense? Okay, so the other thing I know is the equation of the line. The initial. Oh, so that's 0, and I can go. I can find, if I know v final is 25, and I know the acceleration is 0.15 meters per second squared, I can find the time from this. So what is that? 25 divided by 0.15? Because this is the equation of the line, and that's the sort of equation for the area. So sometimes I gotta, to find the area, because I need a time and a final velocity, so I can do the rectangle divided by 2. Sometimes I have to go a separate equation to find the time, which I did here. And so the time there would be, whatever 25 divided by 0.15 is, which I have a calculator for. Did you already do this? Okay, so that's 106, yeah, seconds. So if I put that right here, so 166 is this number here. So if I know that number and that number, I can do 1/2 base times height and get the displacement. So put the 166 right here, multiply by 25, divide by 2, that should be the answer. But that one required 2 steps because the I guess the formula for the area, which is this triangle, I had to go do a previous problem to get one of the 2 numbers. Is that good? Yeah, no worries. So that happens sometimes where like, okay, here's the equation I need, which is the area of this triangle because that's the displacement. But unfortunately, there's a miss. I don't have all the numbers, so I have to go find another equation to get me the missing number so that I can solve this first equation. That's kind of what the logic is. Okay. Another one? Or do you want me to make up one? Anybody waiting? Let me check and see if anybody's waiting. Sorry. Sure, can you just read it to me? What does it say? Uh-oh. Are you still there? Number 8. I should be able to find that. How come I can't see that? Schoology. This is how about this? Yeah, I can't on this my laptop here, the one at school I have it, but I don't have it here, so you have to read it to me. What's number 8? Okay. So it's gonna skid to a halt. So that means it does this, and that's negative 9.4. Is that what you said? Okay. Okay. So that means that the displacement was 34 meters. I'll put that right there. Okay. So that's this. So you want V initial. Actually, this is the one we did in class when I first described this. So that time I don't know, and I know that area. So if I'm trying to find V initial, my first instinct is, well, I won't use the area formula, which is the triangle. I'll use the y equals mx plus b. Okay. I know V final is 0 because it said skidded to a halt. And I know that acceleration is negative 9.4 meters per second squared times t plus V initial. So here, like the one I just did a second ago for Chris, there's one equation here, but I have two things I don't know. So I'm going to have to write another equation hoping to find one of those two things or end up with two equations, two unknowns. So because I don't know this time, the time it took, because that's the number that would go right here, and V initial would go right here, and that's what I'm trying to find. So there's two things I don't know. So let's look at the only other sort of tool we have, which is the area of the triangle. So the displacement, 34 meters, should be 1/2 V initial, because that's this number, times t, and that's this number. Okay, so this was what happened in class on Thursday. I ended up with two equations with two unknowns. So this equation, if I multiply both sides by 2, what is that? 68 equals V initial t. This equation, I don't have a lot of space. I'm going to write it up here. Looks like it's going to be, if I add this to both sides, 9.4 t equals V initial. Okay, so you see what I did there? I did some algebra where I solved this equation for V initial just by adding this term to both sides. Is that good? So now instead of V initial right here, I can put in 9.4 t. So 68 becomes 9.4. This t times this t is t squared. So if I divide by 9.4 and square root, I get the time it took to get to here. Once I know that time, I could come back to right here, plug the time in, or plug it in right here, and solve for V initial. And that's how we did it in class. So this is another one where I had to kind of write both equations. We only have two equations really, area of a triangle and y equals mx plus b. I'll write the two equations and then try to figure out using logic and algebra how to find the missing variables. So this would be divide by 9.4, then square root, and you get, anybody get a t? I think I can do that actually. I have a calculator. 68 divided by 9.4 equals, and then second square root, second answer. I got 2.69 seconds, which I can then put in right here. And so 68 divided by, so 68 divided by 2.69, I got 25 meters per second. Anybody else get that? Or, okay. So that's kind of how you do that. There's really there's an equation for a triangle, an equation for a line, and then you just have to hope you can do algebra until you find the letters that are missing. Okay. How does it get more complicated than that? Unless anybody else have another question? Yeah. If it is AT squared, because that's the box plus the triangle just in a different form, I'll put it on the board. If it makes sense to use that, I don't care. Sure. Like, okay, so let's say you did this. You had a car. It was going, 5 meters per second, and it sped up at 3 meters per second squared for 6 seconds. Okay. So if the question was, what is v final, then I would write y equals mx plus b, because v final equals at plus v initial. Okay. But if the question was, what's the area, or sorry, what's the displacement, I could do a box plus a triangle, or since they gave me the acceleration and the time, this up here, this equation is just like the shortcut for the box and the triangle. So I can get the displacement really easy because I can just go, well, delta x, the box is 5 meters per second times 6 seconds. That's this part. And then instead of having to find v final and make the triangle, like the triangle thing, this one, it's like already did that for me. So I can go 1/2 3 meters per second squared times 6 seconds squared, and you just all in one calculator shot find the area of the box and the triangle really fast without having to actually do a box and a triangle. This right here is actually a shortcut for the triangle part. So the displacement here is this box, which is 30, plus this triangle. This right here, shortcut, if you know the acceleration, it's the shortcut to find the area of the triangle really fast. And that's all that formula was. So it just saves you some time. Yeah. So where the formula came from, let me show you, was in general, this would have been V initial, this would have been A, and this would have been T. Okay. So in general, the displacement would be V initial times T, because that's the box. And then there's this triangle up here where you go 1/2. Okay. How high is the triangle? Well, it's this distance that I'm making all dark times this distance divided by 2, right? But this distance is delta V, because that'd be V final minus V initial. So V final is up here. So I showed you in class where this formula comes from. I'm not going to ask you to prove where it comes from, but here's the logic again. Oh, somebody just try to get in. Hang on one sec. I got a buzz. So I'm trying to find this triangle, because there's the box, there's the triangle. I'm going to add those two areas because the area of this graph is the displacement. So this would be V final. This would be V initial. So this distance right here is delta V. And this distance here is the time. So that's the area of the triangle. But if I multiply this by T over T, this T and that delta V are the acceleration. And these two T's multiply together to get a T squared. So you end up with this. 1/2. This part was A. Those guys were T squared. So that's just shorthand for the area of a triangle if you know the slope. But you're not going to have to prove where that came from. But that's just box plus triangle is the displacement. I hope that makes sense. Huh? Yeah, like when you multiply by t over t, that's actually, if you go far in science, that's a pretty common thing where you're like, I'm going to change the way the equation looks by multiplying something by one and then simplifying, and I get a new looking equation, which is still doing the same job because I just multiplied by one. Yeah, it's like, right. I mean, if I didn't have this equation, I still could have done the problem because I would have had, but I would have had to go like this. Uh, Hang on a sec. I would have had to go V final equals AT plus V initial, plugged in the numbers so that I can get V final. Then I could have done box, and if I know this number and this number, I can subtract, multiply by T, divide by 2. So it just makes me not have to do the problem in two steps because it's like I pre-did the steps and made a formula for it. But anyway, that's pretty mathy. Yeah, I remember. Yeah, and that's still totally faster. Yeah, but it's the same. It came from the same logic. So yeah, it's pretty normal though just to write that equation and not tell you where it came from. But that bugs me, so I didn't do that because I have my own pet peeves things. Okay. Any other specific questions, or should I give you one to try? Okay. What if I did this? Uh, Here's this car. It's going 50 meters per second, and then uh, uh, after I don't know 4 seconds, it slows down at an acceleration of negative 0.5 meters per second squared until it comes to rest. So, what would that velocity time graph look like? Well, there'd be pieces because there's 4 seconds of constant velocity, and then there's this bit uh, where it slows down to a stop. So I'm going to pause for a second while you guess what that velocity time graph would look like. I'll wait just a sec. Okay, hopefully you did this. It went for 4 seconds. It went 50 meters per second. Then, for some unknown length of time, that happened. And what's V final? Thank you. Who's that? Chris? Chris? Okay, thanks, man. So, so how far? If I asked how far did the thing travel for that whole journey, I'm going to have to find this displacement and this displacement, add them up. It's still a box and a triangle. It just came out weird. So this would be like something we've never done, but it'd be a really good sort of level 3 question on Monday. Like, can you take this and go to the next step without any help? So what would this area be? I think 200 meters. Is that right? 50 times 4? And then I need to add this area, and that would be the total displacement for the whole journey. So how do I find this area? Well, I know that number is 50 right there. I know that number is 0. I don't know the time. So that fancy formula we just did a second ago has time in it. That doesn't help me. So, any ideas? Well, here's the trick. Well, let's pretend that's a new a second problem where this is time equals 0 for the second problem. So for the second problem, V initial is 50, and it does that. And so then if I treat this as a second problem, get this area, and then add it to the 200, then I'd be done. That'd be the total displacement. So this problem right here, where I'm just trying to find this area, pretending that's time equals 0, because if I pretend that's time equals 0, then I can say V initial for this section is 50. And I can do things in sections as if each section was its own individual problem. That's the problem. Who was that? Mandy just asked this exact problem a second ago. If you're going 50 and eventually you're going 0, and you know the acceleration, can you find this area? Yeah, I think we did that. Mandy, I think Mandy just asked, was that Mandy? Yeah, that one where it skids. Well, that's what we're doing here. So I can say V final 0. So I can do V final equals AT plus V initial. I'll put 50 in right here. I know 0 is that. Oh, actually, since V final is 0, can I solve this? I know A is negative 0.5. It looks like the only thing I'm missing is T. If I plug numbers into this, isn't the only thing missing T? I think, because V final is 0, V initial is 50. I know A. Yeah, I should be able to find T. If I take T and put it here, then I can do 50 times T divided by 2. That will give me this area, which I will add to the 200, and I'll have the total distance traveled for the whole journey. Does that make any sense? So there's not really a formula for that. You kind of have to break it into little chunks. Here, why don't I give you something like that, and then you see if you can figure it out without me talking. Okay. So let's say here's a car. It starts from rest. It accelerates at 3 meters per second squared for 2 seconds. Then for 6 more seconds, so that'd be 6 extra seconds. So I guess that's T equals 8. Okay, that's T equals 0. Okay, for the next, what is that, 6 seconds, it goes the same speed. So whatever speed it had, it's like it sped up and then just coasted. Okay, if it sped up and just coasted, why don't you just on a piece of paper try to sketch the velocity time graph and see if you can't figure out the total distance it would have covered in those 8 seconds. Here, try that for a second, and then we'll go over the answer. Let's see, I think it's going to go like this, and then like this. Is that, anybody do that? Okay, so now if I want the total distance it's traveled, or the displacement, it covered, there's some displacement during the acceleration, and there's some more displacement while it's going the steady speed. The steady speed is easy. It's going to be like, what is that, 6, well, it's going to be this length, 6 times whatever that is, because there's no 1/2, it's just a rectangle. Okay, so I need to get V final so I can do this other half. Okay. So the displacement part of the first one, I actually could do that, shortcut formula. I don't think it helps me here. Where V initial was 0, and I can find the distance it went for this first 2 seconds by plugging in a 2 there, but I still need the final velocity for the second bit. So I'm not sure that actually gets me anything, but I mean, it's not wrong. So I think what I would do is say, okay, for this first 2 seconds, V final equals AT plus V initial, because that's just the y equals mx plus b. That's a straight line right there. So what's V initial for this first? It's almost like I'm breaking this into 2 separate problems. One for this first 2 seconds, and then one for the next 6 seconds. And learning how to break things into problems is takes practice. So could I find V final for the first bit? V, yeah, V initial is 0. Yeah, that should be pretty easy. It should be like 3 meters per second squared times 2 seconds. So that's 6, is that right? 6 meters per second? Okay. So the area of the triangle is going to be, since I now know that's 6, it's just going to be 6 times 2 divided by 2. That was that, 12. That's 6 meters. So it went 6 meters in the first 2 seconds? Because that's the area of this triangle? Am I going too fast? Because we just figured out at time equals 2 seconds, the final velocity was 6 meters per second. So 6 times 2 divided by 2, that's this area, and that's the displacement for the first 2 seconds. So let's see, delta x, 6 meters per second, 2 seconds over 2, because it's a right triangle, it's a cancel. That's yeah. So delta x for the first 2 seconds was 6 meters. Am I recording? I think so. It says 1 hour and 22 minutes. How can that be? I wonder if I know what it's going to write. Okay, so when I post this video, it might be last week and this week all together. I should have made a new, oops. Oh well. Maybe I can cut that out. So if you rewatch this video later, it might be an hour. You might have to fast forward, whatever. Okay, anyway, I'm not done. What's next? To find the total displacement for the whole 8 seconds. Yeah, so that'd be, see, this is 6. What is that? Is that 6 times? Is that 36? Because it's going to be 6 meters per second times, and the time interval for this box was 6 seconds. Yeah, so the total displacement would be 36. 6 was that 42? So this breaking the story up into multiple pieces and then just treating each piece as its own individual problem is a skill we did not do in class, I don't think. But we could have, and if you could think on your feet, that would be a pretty good problem for the level 3 on Monday. Just saying. Yes. Well, everything I'm writing down. So, okay, if I wanted to make this like turn in quality, let me show you what I would write. Because first of all the work is on my page here. But as a grader, this would kind of suck to try to figure out what I just did. So let me show you how I would present the work so that it's easier to figure out. And I'm going to have to teach this eventually, but I haven't yet. So how do you show your work when there's like these multiple step problems? Because ultimately, your job is to turn something in where the grader goes, oh, I know what they're doing, so you can get your points because you're trying to communicate that you get it. So I think I would go, I need to get this total displacement. Total would be displacement 1 plus displacement 2. And I would label them up here. Isn't that what I'm trying to do? Okay, so that's enough work to tell me as a grader, okay, what are you going to be doing first? So then I would just label this delta x1, and I would do my work right here, delta x1, and that way I can tell that the work I'm going to write below this is trying to find that number. There'll be some new work to find this other number so I can add them. So delta x1, what did we do? We did, let's see, v final equals v initial. Oops, I did it backwards, but that's okay. Y equals mx plus b. So that was 0, and we went v final, and I'm going to plug the numbers in with units. Oops, that's 2 seconds because I was given. So v final was 6 meters per second. Then I can say delta x1 equals 6 meters per second times 2 seconds over 2. Is that the error? There. That's the work to find delta x1. So that's going to be 6 meters. Now I need a label where I show my work for how I got the rectangle, and then I'll add the answers. Is that so? This is how much work, like the minimum, like the best, because more writing just makes it worse. So delta x2 is just a box. So I'm going to go delta x equals, I know that velocity there is still 6 meters per second. I know that this time interval is 6 seconds. So that came out. And then I can say the total delta x like that. So now I've told the grader, this is what I'm doing. There's the first number I found. There's the second number I found. So it makes it so I can follow your work. Does that make sense? So the work you would show is the graph. You can add numbers to the graph as you're going, but you're going to show the original graph with the original info, and then something about, well, here's my logic, and then the work for each piece that you're trying to find. Does that make sense? Okay. Okay. That's all I was hoping to do. And assuming you can all do conversions, can you all go do conversions? Like with areas and volumes? Yep, you don't have to, no memorizing in this class. So if I said 42 gallons and I want that into, cubic meters, I would tell you, let's see, 1 gallon is 231 cubic inches, and then the 2.54 centimeters an inch is still on the board. But but you're only allowed to use the ones I give. You can't like Google gallons to cubic meters and just put that answer down. You have to kind of do all the steps that I'm demanding using these given conversion factors. But yeah, all the conversion factors are given. So everybody know how to do that one, or should we just go do it really fast? I'll just start writing as I wait for someone to talk. Let's see, 1 inch. And then I could go centimeters to meters, right? Or you have to do the cubes out here. You can just write them 3 times if you want. But make sure you don't screw up your calculator. 42 times 231. This cube right here is not on the number. It's only on the unit. But this cube's on everything. So I go 42 times 231 times 2.54 times 2.54 times 2.54, divide by 100, divide by 100, divide by 100, then hit equals, okay? And if that's good, that's pretty much everything I was hoping to cover. Any questions? Anybody there? Hello? Oh, okay, good, thanks.